Okay, so now that we know what a earthquake is and what causes them, so the next thing is to find out what causes the energy that is released in an earthquake. And so this is going to be called elastic rebound theory. So all materials, when you start to apply a force to them, at first they're going to stretch elastically. So imagine that you've got a rubber band and you put a weight onto it. At first it's going to start to stretch, so it's going to behave elastically. Now if you were to take off the weight, then that rubber band is going to return back to its original shape. So that's how you know it's behaving elastically. So rocks will do the exact same thing. Whenever you start to apply a force to a rock, at first the rock is going to bend. Okay, but then it's going to reach a point at which it's going to start to behave plastically. So again, you can do this with a rubber band, put some weights on it, but eventually you're going to put so much weight on it that whenever you return it back to its original, when you take the weight off, it does not return back to its original shape. So it has then been deformed. And so we're going to find examples of this in our next lesson when we start talking about anticlines and synclines, domes and basins, where the rocks are permanently distorted. Well, we want to go one step further beyond it behaving plastically, and we want it to rupture. So again, if you take your rubber band and you start putting weights on it, it's going to stretch and stretch and stretch, and then finally it's going to break. It's going to rupture. Now when it ruptures, you're going to see that rubber band snap back, and if you're not careful, it's going to hurt your fingers, because in that stretching it is storing energy, and then when it ruptures, all of that energy is going to be released. So in these pictures that you see off there to the left hand side, that shows a rock that is being stressed like this, so it's going to be shear, where you got one force on one side and then the other force is in the opposite direction on the other side of what will become the fault. And you see how it's being distorted and it's behaving plastically, and then finally it ruptures, and then when it snaps, it's going to release that energy, and then that is going to be the earthquake. So what determines the energy of the rupture? So how much energy can an earthquake give off? Well, it's going to depend on the length of the fault. It's going to depend on the area of contact. So like for example, if you've got two rocks like this and they're going to be sliding like this, then the area of contact is going to be the area that they are in contact with. Okay, the amount that they slip is going to be the amount of displacement. So that also goes into our calculations of the energy released. And then it also depends on the amount of force that's being applied to the fault. And then it also depends on what type of rock it is. So like a limestone, if you fracture limestone, it's going to give off a certain amount of energy. But if you fracture granite, it's going to give off a different amount of energy. All right, when we come back, we're going to talk about the different kinds of waves that are released during an earthquake.